Right, everybody, this is video 2. So now we look at angles. So the first part, what is an angle? An angle is a turning around a fixed point. It's when two rays rotates or turns around a fixed point. So if I look at a protractor, this is a 360-degree protractor. This is my fixed point. There where the two rays, this is the one ray, this is the other ray. They come together there and they turn around that point. So when we talk of angles, we talk of turning. And what is the relation of the one ray to the other in terms of how much it turned? So if we look at angles, if the two rays lie together and we say this is at 0 degrees there, and the one ray turns, it forms an angle, and there is your angle. And the angle that is formed is measured in degrees because we measure how much it turns. Can you see? You can't measure with a ruler. So we measure it turns from there to there. So if I have to draw it, this angle, there is my one ray. Let me do this with straight lines. There is my one ray. And then I have another ray and it turned and it formed an angle. This is my angle. It turned from there to there. So the size of an angle is measured in degrees. So degrees measure how much it turns. And if I look at an angle, just general terminology, we call that the arms or the sides of an angle. Where they meet or the fixed point is called a vertex. So when I look at angles, and you must know this from last year, when I look at a circle is 360 degrees. So if an angle is formed and it turns and it stops somewhere between 0 degrees and 90 degrees, it forms an angle like that. And what do we call it? You must know that. It has a very sharp vertex or point. Yes, we call it an acute angle. Then if it turns and it stops at 90 degrees, it forms an angle that looks like this. And the amount it turned is from there to there, which is 90 degrees. And as you know, what do we call a 90-degree angle? We call it a right angle, right? And there's my square, so this is a right angle. So now if this side turns from 0 and it goes all the way past 90 and it stops somewhere there. So it stops somewhere between 90 and 180 degrees. It forms an angle that looks like this. And it turned from here to there. And it's now lying between 90 and 180 degrees, which means this is now an obtuse angle. Obtuse means it's a bit blunt, it's not very sharp. So now, if I have a rotation that starts at 0 and it goes all the way past 90 and it stops at 180, it forms a straight line. So now my angle looks like this. It basically is a straight line and it turned from here all the way around to there to 180 degrees and it formed a straight line. We call that a straight angle. So right, let's look at the other one. You should know all of these angles. Where is my ray now? So if it starts at 0 and it turns and it turns, it goes past 180 and say it stops somewhere there. Now it lies between 180 and 360 degrees. So it looks like this. There is my 0 degree arm. Oh, sorry, let me use straight lines. There's my 0 degree side. It lies on 0. And then it turned, the other arm turned, or the other side turned around, and it stopped somewhere there. So the other side is here. I get an angle that looks something like that. So it turned all the way around like that, which means now you have a reflex angle. So the last one that you're supposed to know is if I take my side or my ray. What is it now with you? So let's start at 0 again. And it turns and it turns and it turns and it goes all the way around and it stops again at 0 degrees there. What do I get? What do I call that angle? Now draw it, it will look something like that. The two arms are now together on 0 or 3, and the other one turned from 0 and it ended at 360. So my turning is now a full circle. Like that. And I call that a revolution. So this is classification of angles, and I hope you understand what an angle is, and that we measure it in degrees because we measure how much it turns. So right, I want to go straight to the examples in worksheet 1. Let me just close the protractor. So I want you to do an example to show you what I expect from you with the exercise 1. So the first part of the exercise is we're going to look at diagram signals, and I want you to practice and to put in diagram signals in diagram. So I've given you a diagram, and then I've given you some information. This information is not on your diagram. So for your exercise, you have to go and redraw your diagram, and then you have to put the diagram signals for the given information in your diagram. So what does this mean? I'm going to read now. I start with what is given, and if I read this, it says AB, so I'm talking about the side. There's 2 points from A to B, and what is that symbol? It means it's parallel to another side from F to C. So from F to C is that side. So I have to now put that diagram signal in my diagram. What do we use for parallel lines? We use arrows. So you are now going to go and you can use, I'm still going to use red. I'm going to now put an arrow on the side AB, and to show that it is parallel to FC, I'm going to put the same one arrow on FC. Then, so I'm done with that one. So the second given piece of information that I have side, again I've got 2 points from F to E, so this is from F to E, which means it's this side. FE parallel to, and it's parallel to the side from C to D, because that's also 2 points. So it's parallel to this side, which is from C to D. So to show that this is not the same parallel side as these two, I'm now going to put in 2 arrows there. So I'm going to say that FE is my 1 from F to E is parallel to side CD, and I put 2 arrows there to show that these 2 sides are parallel and these 2 are parallel. So I'm done now with that one. So now I have to put in this information. That means I'm talking about an angle. So it's angle E1. Where is the angle? There is the E1 is the angle that's formed there. So that angle is from there to there. So you can use various things for angles. So I'm just going to use arcs. So I'm going to use that. I'm going to make my line a little bit thicker so that you can see. Let me go there. So I want to see that angle E1, which is that angle from there to there. is equal to angle B. Where is angle B? There is point B, so the angle is that one. And that is also equal to angle C3. There's point C, and 3 is that angle from there to there, so I put that in. You can use dots. You can say it's that is equal to that, equal to that as well. You can use crosses, whatever you like. But you must use the same thing in those two angles to show that they are equal to each other. So now that one is done. So now look, I've got another pair of angles. I have to show that angle E2 is equal to C2. So let's use another color. I'm going to use green now. So where is E2? That is E, and this is the sec. It's from there to there. And to distinguish it from that one, I'm going to make two arches. So that's angle E2, and it's equal to angle C2. So where is C? And this is angle C2. So I put the same off there. And now I can see very clearly when I look at my diagram, all the information is on my diagram. So for exercise 1, number 1, that's what I want you to do. So I'm going to just do the second example. Number 2, we're going to do the opposite. You are going to look at the diagram. And then you are going to write down all the information that is given in the diagram that you can see. So let's start. Let's look at that. I just want to change the color of that. So I see a lot of arrows here. I see one arrow there on that side and one arrow on that side. What does it mean? It then means this side. Let me use this color. This side is parallel to that side because there's arrows on that side. So how do I write it? I am going to say you can use any point here on this. You can use from D to B because it's the same side as D to G. But so I'm going to use from D to G. So I'm going to say DG. And because they are parallel, I'm going to use the symbol for parallel, which is the two vertical lines. And DG is parallel to CE. So I'm just going to put that in. CE. That is given, and it's given in the diagram. So what else can I see? There is like two arrows there and two arrows there. So it means I've got another parallel side, which means this side from there to there is parallel to this side. Because I've got the arrows in my diagram, I know that. So what is this side? Is from A to C. I'm going to write A, C, and the symbol for parallel, parallel to DF. Good, so I've got that. So what other information do I get out of this diagram? If I look at the angles, they tell me that they give me the size of this angle. This angle is from there to there. So how would you write that? That angle is from A, the vertex is B, so that angle goes like this. To use some of this color, that angle is there. There is that angle. Do you see that? So I can, when I write an angle, I can say it's angle starting at A, say A to B. B is my vertex, and because B is my vertex, I'm going to show that that is the vertex from AB to G. An angle has 3 points. And why can't I just use B? Because there's two angles around, well, there's actually 4 angles around that point. I want to refer specifically to that one. So I'm going to say ABG is equal to 110 degrees.